So hello guys, in this video we are going to talk about the confidence interval. So the first thing that I want to tell you about the confidence interval that I should have filmed this video after the central limit theorem, because this confidence interval related to another concept which is called the central limit theorem. So let me give you a short introduction about the central limit theorem before we moving towards our main topic of this video is confidence interval. So if you haven't watched my central limit theorem video, then the link is in the description and you can watch that video from the I button too. So the first short introduction about the central limit theorem. With the suppose if we have a large population and we want to calculate the mean of this large population, then without being because it's very difficult to get the data from this large population, so we used to get data from the samples, right? Different samples, and after getting the data from the sample, we are going to calculate the mean, and whatever mean we have, we are going to calculate the again we are going to calculate the mean of this mean values. So this is the all about the central limit theorem. But now in the confidence interval we are going to check that how confident we are that our mean is true, our mean is real, right, of for the population. So how confident we are about our mean that we have calculated from the central limit theorem. It's quite useful for the population, it's quite real for the population. So about this whole thing we are going to discuss in this confidence interval video. So basically in the confidence interval we have a function, we have a formula, which with the help of this formula we can easily calculate that how confident we are about our mean. So there are some prerequisites about this confidence interval. We have to calculate the central limit theorem first, because we need a population mean, because we want to check that how sure we are that population mean is fall between a particular range, because confidence interval give us a range where we have a lower limit and another is called a higher limit, upper limit, we can say that. And we want to check that how confident we are that our population mean fall in this region, fall in this interval. So basically generally data science used to calculate 90%, 95% and 99% check. 99% they try to check that that particular population mean fall in this range. Okay, so let's discuss the formula of this confidence interval first. So confidence interval, you can represent the confidence interval as a ci, and the equation for this is x bar plus or minus, here is a z alpha divided by 2 into this is a sigma divided by root n. Okay, so x bar means, what is the x bar means here? Because as we discussed in our central limit theorem video that it's very difficult to get data from the large population, so we divide the whole population in samples and we got a mean from the sample, we get a mean from the sample, right? So this is the sample mean here. You can pick up any samples, right? Suppose you have a population of 1000 people, and you have a population of 10,000 people and you divide the whole 10,000 people in the different in samples, and each sample size is 30, right? So you create a sample and in each sample you pick up 30 people from this population and make them a group, right? You made them this group, so this group is number one. So there are total n number of groups here, right? So there are total n number of groups. You can pick up any group from them and you can write a mean here. Now we talk about the alpha here. What does it mean alpha? Alpha means it's a significance value. You can calculate the z. You have a z table. With the help of z table you can calculate this value. Right now this is the population variance, sorry, this is the population standard deviation, and this n represent the number of sample size, right? So this is how many data points is currently we have in a sample that represent the n. Okay, so this is all about the formula. Now, so up to this point we have discussed what is the confidence interval, why we use it, and how this confidence interval is related to the central limit theorem. So let's try to implement this concept in a Jupyter notebook. So here currently I have a Jupyter notebook and I've imported NumPy library with the alias of NP. So here I'm going to create a population with the help of some random numbers, randint. So I'm using some numbers and I create 1000 samples for 1000 data points for the population, and from the population I've got, as you can see here, there are total 1000 data points in the population I have. Now I'm going to create a sample. Before I'm going to create a sample, let me show you the mean. Okay, so this is the mean of this population, and here I'm going to show you the standard deviation because we are going to use the standard deviation in our formula, right? Let me store this population, let's go std in this, right? Okay, so now I'm going to create a sample from the population dot. I'm going to get some random numbers, 10 to 40, right? So these are some of them the numbers, and I'm going to copy this value in the samples. So I have a sample like this, as you can see here. Currently I have some values. Let me check that how many values I have. So we have a 30 values. So as you can see here, we have a value is n, number of n is equal to 30. Now we are going to calculate the formula here. Calculate the formula. Okay, so here I'm going to calculate the confidence interval. For this we am going to calculate the sample mean first. Sample mean, which will be the x bar for us. So it's different, right? As you can see here, the mean of the population is differ from the mean of the sample, right? So I'm going to use sample dot mean here minus, we are going to use some z values. So let me give you some representation. Here I'm going to calculate the confidence interval on base of 95%, right? So how this is going to look like? Okay, so here, so we want to, so suppose our data is follow the Gaussian distribution like this, where 95% of the data fall in this region with the population mean, right? Whereas 5% of data fall in this region, 2.5% in this region, and 2.5% in this region. So this value is going to be our alpha. So our total alpha is 5%. That means alpha is 0.05, right? So if we calculate the z alpha by 2, that means z 0.05 by 2, that means z 0.025, right? And in order to calculate the z 0.025, we have some functionality like this: 1 minus, so this whole graph is represented by 1, because the whole data point is represented by the 100%, right? And if we only got this 5%, right, if we want to subtract this 5% and we want a region of 95%, then we are going to subtract this like this: 1 minus 0.05. So right, so here 0.025, and I got a value which is like 0.975, right? So I'm going to check this 0.975 value in Z table. So here we have a Z table, and we are going to search 0.975. So here 1.9 and 6. Okay, so we have a value 1 which represent the 1.9, and another value is 0.6. We are going to add these values, so 1.96 we have. Okay, and we are going to use this value in this formula. So the formula is going to be like this: 1.96 into, we are going to calculate the population, we are going to multiply with this value with the population standard deviation of the, okay, and divided by the root and p square t square root of n, right? So this is the lower limit, lower ci. Lower ci, because we use minus here, and we are going to calculate the same thing for the upper ci. Right, so I'm going to see ci. As you can see here, so this is the lower underscore ci, and this is the upper underscore ci. So as you can see here, we have a two value 37855 and 58663, whereas the population mean we have is 48876, right? So as you can see here, we have a range. So as you can see here, we have a range which is 37885, and what is this another 58663, 58663, whereas the population mean we have is 48876, 48876. This is the population mean, right? Population mean, which is falling but in this range, in this interval. So I'm 95% confident about this. So suppose if you move towards a less confident, right, if you want to check that for 90% confidence, then this value, this range is going to be a smaller. So this is all about the confidence interval, and let me summarize this for you. So in this video we discuss how we can use central confidence interval in the data science, because if you want to check the central, we firstly if we have a large population, then it's quite difficult to get the data from the every single person. So we divide the whole population into samples, and we come up with a population mean with using such sampling distribution technique, right? But we want to check that how confident we are about the mean that we have calculated on the basis of sample distribution. So at that time we have another theory called confidence interval. With the help of confidence interval, we have some formula, and we are going to perform such operation on population standard deviation, z table, and simple mean, and we come up with some range and confidence about that particular range, right? So this is all about the confidence interval. Thank you for watching.